In this second session, we're going to use selection in C# and we're going to be introduced into how to refactor our code. We're going to look at the principles for creating readable and maintainable clean code. As I say, we're going to refactor our code to reduce what are called code smells. We're then going to look at how we can measure the quality of our code. Then we're going to look at how in C# functions can return values and accept parameters, and then how in C# we can select alternatives, and then we're going to do some black box testing. So what we're trying to do is incorporate best practice in everything we do. So if you look at the coding guide in the main wiki repository, you'll find more details of this. In particular, we're looking at readable code, and there are marks for this. So you must have block comments for all classes and methods. You must consistently indent the code. You must separate your code lines into groups. You must use consistent naming and have a consistent naming of both files and folders. These are the architectural principles we'll be following, and in particular we want a method to have a single purpose, a class to have a single purpose. Encapsulation refers to keeping methods and attributes private if they don't need to be accessed by other classes. And one of the key principles is don't write the same code twice. This is in particular when we move on to database in your second year. Same principle applies. If you'd like to, you may pair up and work on apps in pairs. The idea behind pairing is that two people share a single workstation with one person using the keyboard and mouse, and they're referred to as the driver, and the other person is looking at the overall direction of where the code is going and is the navigator. And it's expected that you will swap those roles, say every 30 minutes. So for example, the driver might say to the navigator, I'm going to add a method called foo. The navigator is saying, wouldn't it be better if we called it bar? The driver might say, I'm going to add some code to do this to this method. And the navigator says, I think that would make the method too long. So you have a dialogue, a continuous dialogue over what is the best way to carry on with the coding. Now in terms of assessment, each student in the pair will get the same marks. But I need both names to be added to the class and the shared repository, and any screen output as well. If students don't get on, are starting to argue and abuse each other verbally, we don't want that to continue. You may separate again. And you may only carry on the same pair for a single app. You may form a second pair for another app. Now I've skipped over the details of those very quickly. So here is the main repository, BNU CO453 console apps 15, and here's the main wiki. So you'll see the home page is the module scheme, and if you want access to the presentation, it's there. The videos are on a separate page, pre-lesson videos, so you can go there to find the videos. But the things I've been talking about are in the coding guide. In particular, this is a good reference which gives you much more detail over how commenting should be done, how you should be laying out the indentation. Say we're following style 2. Don't put in comments that don't add any information. How to group lines of code, your consistent naming, your principle of don't repeat yourself, and so on. So you have those guiding there. In particular for Microsoft and C#, there's all the, if we just look at, I don't know, one of those, this is Microsoft documentation. But I will be going through it in the lessons. But if you want to look at more details and know where it's come from, here's the place to go. Here's your architectural principles explained. Although some of these are too deep, don't worry about dependency inversion. You will need it in the second year, but it's not needed in the first year. So there's single responsibility, there's don't repeat yourself, and there are others you might want to look at. We're going to be moving into refactoring, and here's the link to a whole website on refactoring. It also covers design patterns, which we'll be bringing into further lessons. And then the key reference is to the Agile Alliance and these 12 principles, which I mentioned in the first session. But if you want more details on pair programming, it's here. Okay, so there's where all the details are, in that one wiki page called Coding Guide. Visual Studio has built into it the ability to analyze your code. See, there's an analysis menu here, and in particular it can calculate what are called code metrics for your solution or just the app project. These are displayed down here in this window here, and if we open App01 and select the distance converter, you can see you get these measurements: maintainability, cyclometric complexity, and so on. So here are the measurements as they stood before we added the extra 2 features. It's only got 1 feature in it at the moment, and maintainability is 83. And if you look at the index here, providing it's over 20, that is good. Anything below 20 though is better, is not so good. For complexity, the lower the better. It's a 5 at the moment. For coupling, the lower the better. It's 2. Again, lines of source code, the lower the better. There's 57 lines of source code, but only 14 actually do anything. So we've got these measurements we can use to see whether we're improving the code quality or we're not. By now you should have added 2 more features, so there should be 3 features in your distance converter. So it should be possible to convert miles to feet, feet to miles, and one other distance. But we still got problems. There should still be issues unless you've gone ahead of what I was expecting, because the user can't select between these 3 conversions. Our output heading may be too specific, and you probably got unnecessary code duplication now, in that we've got 3 input distance methods, 3 output distance methods, and 3 convert methods. And we need to remove this unnecessary duplication by refactoring. So here is a website devoted to refactoring, i.e. trying to keep our code clean rather than dirty, trying to remove any poor code smells. And there are a whole load of refactoring techniques we can use. There are 68 ways, and there's a whole books on refactoring. Obviously this is the first year of the course, we're going to keep to just a few of those ways. It took me all of 10 minutes to convert stage 1 into stage 2. I'll just go through it briefly with you. I added a second constant, the number of meters in a mile. I then copied the run method twice, and I've changed their names. So I put miles to feet, feet to miles, and miles to meters. They're all very similar, as you can see. You could call them convert miles to feet, but as the class is called distance converter, to call them from the program it's converter dot. So although I haven't got a verb, it implies a verb. Converter dot miles to feet implies that the miles are going to be converted to feet. So there's the one situation in which you can get away with a method name which doesn't start with a verb. But I've definitely got unnecessary code duplication. I did the same with the input, so we had an input miles. Copied that and pasted that in twice. In fact, we only needed it once. Now you can see I did it twice without thinking. This one's greyed out because I haven't actually used it. And they're virtually the same, except that this one asks for miles, this one asks for feet. This one converts the value into miles, this one converts the value into feet. The calculations are slightly different in that when you convert miles to feet, you multiply the miles by feet in miles. When you convert feet to miles, then you divide the feet by feet in miles. Otherwise we've got 3 calculate methods that are very similar, and we've got 3 output methods that are very similar, except that that word changes, that word changes, that word changes, and that word changes. So if I run it for you, you'll see the deliberate mistake. So I'm asked for the number of miles, so the obvious test to start with is 1.0. I get 5 to 80. Then ask for the number of feet, 5 to 80. I get 1 mile. And if we put 1.0 miles, we get 1609.34 meters. But notice the heading is wrong. Convert miles to feet. Convert miles to feet hasn't changed, and it should have changed. Also, this is the old comment. It only talks about converting a distance measured in miles and converting it into feet, when now the program does 3 features and they're not listed in that comment. That comment should have been updated, as should this version number. I'm updating that to version 3. I'll leave you to update the comment. So I'm now going to change the output heading so it doesn't say the same thing all the time. So it's just going to say distance converter now. But that's not enough. We need to know which distance we're converting. So in each of the things, what I could do is follow the output heading with some further rights. First one is converting miles to feet. Okay, let's just try that one for a moment. Okay, so it now says distance converter, and this now says converting miles to feet. Please enter the number of miles. So that's much better. But the problem is, I'm going to need the same thing here. And I can do that. I can do the copying and pasting again and change the names. But again, that's unnecessary code duplication, isn't it? So what I'm going to do instead is, that should be part of output heading. So I'm going to move those lines down to underneath output heading. Put a blank line there because they're slightly different to the first lines. Okay, but now we've got a problem. This says miles to feet all the time. And this is where our refactoring has got to come in. So we're going to use two refactoring methods. One is to extract the lines as a method, and the other is to use a parameter. This will sort the thing out. Extracting the lines, the duplicated lines, as an extra method, and using a parameter. Okay, so that's what's going to change in each time we call output method. We want that to change, so that's where we have to introduce the prompt to the user as a parameter. So that's what the brackets are for. We want to pass into this method a different prompt each time we call the output heading method now. So if we go back to here, we're outputting the heading, we can now put our prompt here. So the first time it's converting miles to feet, the second time it's made a mess of that. Anyway, there we go, and we see instead of having 3 lines of code there and 3 lines of code there, we've got 2 lines of code, and what's different is being passed as a parameter. So if I just run that for you, you should see now that, oops, no, I can't run it until I put a prompt in here. Notice the red squiggle there indicating I hadn't got it right yet. Okay, so it said converting miles to feet, how many miles? Now it's saying converting feet to miles, how many feet? And now miles to meters. There we go. And we have refactored it. We've refactored it by putting the extra code into a method. So we've extracted that code into the method down here. Those lines have been extracted into a method, and we've also added a parameter to overcome the unnecessary code duplication. The next code duplication I'm going to eliminate is this input. We've got input miles, possible input meters, input feet. Difference being what we're actually asking the user to input and what we want returned: number of feet, number of miles, number of meters. Okay, so what I'm going to do is turn one of these methods into a more general method. So instead of inputting just miles, it'll input any distance. So it's going to be input distance. I'm going to call it input distance. Okay, it's going to need a string prompt. So instead of miles, instead of this prompt, we'll have a prompt that's been passed in. So there's where we use the prompt. We'll still have to get it as a string value. Notice in C# there is string with a capital S and string with a small s. The guidance is to use the small string, unless you particularly want to use complex methods from the string class. But the return value is different, so instead of, we don't know whether it's miles, meters or feet, we are just going to return a value. We're going to return the value that's converted to a double. So here's where we change this for the first time. Instead of a private void, we want to return a double. Before it was returning nothing, now it's returning a double. Okay, so here's where we were using it. So I'll go to this one first. Here's where we want to convert miles to feet. So what we want back is miles. Okay, so there's the prompt. The prompt is please enter the number of miles. And that's our general purpose input distance. So we need to use that in place of these. So here now we want feet, not miles. And here we want miles. And let's build that. Okay, it's happy. So now that we've done that, we've got a general purpose input distance. We don't need a specific input feet method. That can go. And we don't need a specific input meters method either. That can go. Now to build that, we have now reduced the line count by 6 or more lines and improved our ability to maintain this program. Instead of having to maintain 3 different methods, we only have to maintain one method. You could take it a stage further, because basically the message is the same there, but I think I won't. I'll leave it. Okay, let's make sure it works. And it does. So it works the same, but there's fewer lines of code. It's less complex. Let's just check, let's analyze our code metrics, and we can see the distance converter now has fallen in terms of complexity from 15 to 11, and in terms of code from about 35 to 29 executable lines of code. So we've improved our metrics. I'm now going to remove the unnecessary duplication in the output methods. You can see there are 4 pieces of information that change: miles to feet, feet to miles, as well as in there in the message itself. So there are 4 pieces of information we want. Okay, so to generalize that, we'll convert it into an output distance method. Now, first of all, we need what I'll call the from distance. What distance are we converting from? Then we need to have the name of that unit, the from unit. So the from distance might be 1.0, the from unit might be miles. Now here's a case in point where the line's going to get too long, so I'm going to fold it over there. In fact, I might fold it over here. If you fold it over, make sure they are indented. It happens automatically with Visual Studio. So we're converting a from distance into a to distance, and there'll be a to unit. So for example, there might be a from distance of 1.0 miles to a to distance of 5 to 80 feet. So now I'm going to change the right. I'm not going to use what the usual concatenation where you add pieces of string together. I'm going to use what's called interpolation, which starts with a $sign. So it starts with a dollar sign, and then we have quotation marks. So wherever you have a variable, the variable goes in braces. So our variable will be the from distance, and then we need don't need a plus sign anymore. We don't need a plus sign because we're not adding things together again. So we've got the from distance and the from unit. So it's going to say 1.0 miles is, then we need the to distance, in braces, and then we want finally the to unit. Like that. And then we can close the quotation marks. Okay, so we've got 4 parameters. The distance we're converting from, the unit we're converting from, the distance we're converting to, the unit we're converting to. Now unfortunately you can't break that quotation mark up by putting, you can't do that. That'll cause a problem. Oh, actually it won't. Look at that, Visual Studio has done it for me. It's closed the quotation mark there, put a plus sign, you can break it up. Oh, I didn't know that. Thank you, Visual Studio. So I have broken it up because that was getting too long, that line. Okay, so we've now got a general purpose output distance method. We can get rid of these 2. And we just need to use this now. You can see where we need to put the 4 parameters now. Remember there's 4 parameters. I think if you put an open brackets in, it should prompt you. No, it doesn't prompt you. Alright. So for output, actually it doesn't prompt you because we aren't using output distance, are we? Now it's prompting you, thank you. So we want a from distance, from unit, to distance, to unit. So the from distance is miles, therefore the from unit is miles. The to distance is feet, and therefore the to unit is feet. Now here I think we can minimize that because that is the same name as that. But that's a variable that contains a value like 1.0. So we can't just have miles there. What we can have though is the name of miles. So that'll give us miles as a string, and we'll have the name of feet. And that avoids having unnecessary strings. I think now with these 4 lines, I think to make it more readable, I'd probably break them up like that now. Okay, so that's our miles to feet method now. I've only done the 1. Right, I'm going to have to, I'm going to have to change them, aren't I? Yeah. I'm going to have to do all 3. So I'll do the other 2. Okay, I think we're there. Again, test it. And we're fine. Let's check our code metrics. Our maintainability hasn't changed that much, 81. We have dropped in cyclometric complexity. We have dropped in lines of code. We're now left with the final duplication, which is in the conversion methods themselves. But let's look at this in more general. If we look at imperial units, there are at least 4 of those we can think of. If we look at metric units, there are at least 3 we might want to use. If we wanted a design which covered all possible conversions, that would be 7 times 7 minus 7, which would be 42 possible conversions. I'm not going to ask you to do that, you'll be pleased to know. We'll just stick to 3 units, miles, meters and feet. And that's 3 times 3 minus 3, which is 6 possible conversions. But I would like a design and a refactoring of this program in a way which could have coped with all 42. So we do need a new design. If we look online to Google have already done this, and if you just Google feet to meters, you'll find that you comes up with a browser app which allows you to choose distance measurements in a whole variety of units. And you can choose what you're converting from to what you're converting to, put in the from distance, it'll work out the to distance, exactly what we're doing here. So our new design needs to be able to cope with as many different distance units as possible. So the first task for the user is to select which unit they want to select from, which unit they want to select to, then put the from distance in, then the program will do the calculation and we can output the to distance. So as well as refactoring, we are going to enhance the program from 3 features to 6 features. So the comment needs to be adjusted accordingly. And we need to introduce new variables. So instead of miles, feet and meters, we're going to have a from distance, a to distance, a from unit and a to unit. And we're going to need 3 conversion constants in order to do this. And we also need 3 strings, the units themselves, feet, miles and meters. So please make sure you've saved all your changes up till now, because this is going to be a major refactor. So I've just completed stage 2. So I'm going to commit and push those because I know they work. Okay, so we're moving on to version 0.6, and this comment is reasonably accurate. I'll just put a brackets there, the from unit. So we've mentioned the new names. And that's going to be the to unit. Okay, now I said we needed 3 constants. So there's the 3 constants we need. And we're going to take out these specific units. We're going to go to a more generalized unit. So we need a from distance, okay, so we've got our 3 new constants, which are the names of the 3 units, and we've got 3 new variables. So 2 new variables will take out the old variables, which of course means the program will no longer run. I've also added 2 more attributes, private attributes, the from unit and the to unit. So in order to minimize disruption, let's put a constructor now in. so that we can set default values. So I'm going to set a default value so that the from unit is miles, and the to unit is feet, our original conversion from miles to feet. Obviously these distances can't be set yet. So here, when we output a heading now, we'll use this string interpolation again and say we're converting from and that's going to be the from unit, and it's going to be the to unit. Okay, so this is going to be the from distance, and that's going to be the from unit. Okay, we're not sure about the calculation, what calculation we want yet, so I'm taking that out. But we should be able to change these to the from distance, the from unit, the to distance, and the to unit. Okay, so that actually compiles, and I'll take out these other two methods so our only problem is we don't know which of these calculations to do. Okay, it still doesn't compile because obviously we have these calculations here, so we don't really want specific calculations because there are 6 of them to do. I'm going to take those out as well. So at this point I'm hoping it might compile. Okay, so it does compile, apart from the fact that we're not going to do that anymore. So we have got it back compiling now, although if we run it, it'll ask for the input distance and it's not going to do any calculation. So I think what we'll find is the output distance will be 0, I imagine. So we enter the number of miles, 1.0 is no feet because we haven't done any calculations, that's fine. At least it compiles again. Okay, there are 2 more changes we need to make. The name is no longer appropriate. So here's a case in point where we're going to select the name and use the refactor rename, which will update 2 references in 2 files. It goes across files. So please don't just change it manually, use the rename. So this can now be called convert distance. So I'm going to apply that. So it changes it in this file and also it automatically changes it in the other file. The next minor change is these are now all global variables. So therefore they are accessible to the output distance method, so we don't need to pass them, so we can simplify that down to that, and that should still compile, and it does. So that's a slight simplification there. The next thing we must do is allow the user some choice of units, because at the moment they're fixed. We'll need to do it there. Okay, so we're going to ask the unit to select the unit. So we need the from unit, so we'll ask for the from distance unit. And we need to do the same thing again with the to unit. And then we can put our heading, say telling user which unit we're converting from and which unit we're converting to. Only issue is these methods don't exist. Well, fortunately we can just ask for them to be generated. So you'll see it's generated a private select unit here. It has got a string parameter, although the name of the parameter we can change to prompt. And at the moment it does nothing but throw an exception. That's done to remind us if we ever try to use this select unit that it doesn't work yet. And we need it to work. At least it is compiling again. Now we need to introduce the new concepts of how users can select between alternative actions. So this is very similar to Java. If we have a method that converts a mark to a grade, for example, we can use an if statement and say that if the mark is greater than or equal to 70 and the mark is less than 100, then the grade is first class. And you have the same operators available in C# as are available in Java. An equals operator, which is a double equals, a not equal to, greater than or equal to, less than or equal to. And you can combine conditions with ands, ors, or nots. You have to be a bit careful about this. So 3 is greater than 1, but 5 is not less than 3. So therefore that whole expression is false. Whereas if we say 3 greater than 1 or 5 less than 3, it would be true. 3 is greater than 1, but the not in front of it makes it false. 5 is not less than 3, but the not in front of it makes it true. Okay, so we're going to use the if statement. We're going to put out a menu of choices, prompt the user, ask them to enter their choice 1, 2 or 3, and set their unit to one of those choices, and then return it, giving them a message telling them which unit they have selected. There is a deliberate mistake in that, which hopefully you will have spotted. So let's give this a try. Okay, so here it is written. There are two things wrong with it though. The first one is, well, what happens if it's not 1, 2 or 3 the user enters? Well, we're going to return choice rather than a unit, which is not correct. So we have to be careful. So it is possible the user will not make a sensible choice, 1, 2 or 3, in which case I'm going to return null. The second thing is that this method is too long. It does two things. It displays the choices and it executes them. That's two different responsibilities in one method. It's too long. So we're going to split it. So we're going to extract this part, which gets the user's choice. And we're going to use a refactor, quick actions, and I'm going to extract a method. They've changed this. Okay, what do I want? I think I want this one. Don't know how I indicate that. How do I indicate that? Oops. What's it done? Yes, it's done it. Okay. Okay, so it's split this now. It's created a new method, and I'm going to call that method display choices, and apply that. So it's going to be displaying the choices. And the second part is executing the choices. That's all to do with executing the choices. So again, I'm going to do a refactoring, extract a method and apply. yes, again, so this one's going to be execute. Oh dear. Okay, that went wrong somewhere with that. Execute choice. This has to be execute choice. The refactoring doesn't work as smoothly as it used to. So let's see. So what we want to do here is we want to return a string. So that's going to, yes, it's passed the choice to the method from select unit. Checked what the choices are, and it returns either feet, meters or miles or null. So that's one way of splitting up, extracting methods so that they're broken down to simpler methods. Okay, so we've now got our select unit. Let's just check whether it works. Okay, we've got a build error. I have missed a semicolon out there. Okay, please the X. So we want, let's do feet, from feet to miles. Oh, gone feet to meters, sorry. Number of feet, 6 feet. Yes, well obviously the calculation still doesn't work. At least we can now select the from distance unit and the to distance unit now. Okay, finally I'm going to add back the calculation. So I'm going to add a method called calculate distance. Again, that method doesn't exist yet, so it's generated. Okay, so now we have to check what the units are. So I meant to mention earlier that there are two ways of checking a quality of strings. You can use the dot equals method, or you can just use the double equals. So if we do our miles first, so if the from unit is miles and the to unit is feet, that's one of the ones we've done before, we know that here the to distance is going to equal the from distance multiplied by feet in miles. If we do it the opposite way around now, where the from unit is feet and the to unit is miles, then you have to do a division. To distance is going to equal the from distance divided by feet in miles. Okay, I'll leave you to do the rest. That's not complete yet. There are 6 possibilities here. But hopefully now 2 of them will work. So the from distance is going to be miles to feet. The heading's coming out in the wrong place. That heading should have come out first. 1.0 miles is so many feet. Needs a little bit of tidying up, but we're almost there. In terms of tidying up, we need this heading to come out to start with. When users have put a selection in, we need a confirmation what they have chosen. We also, some of these prompts are coming far too close to the left-hand margin. So I'm going to change all that. So I'm going to move the output heading back so it was the first thing we did. Problem is though that the output heading did write out a prompt which was a confirmation of what conversion was being done, and we can't do that now because we don't know until they've entered the units. So that has to come out. That's all we can do for a heading now. But when they do make a choice, we do want that choice confirmed. So here's where we get the return is here. So I'm going to actually get the unit there. So I'm going to do that. Get the unit back from execute choice so that we can print it out, confirm the choice. Always put a space. I'm putting a single space now, so it's not too close to the left-hand margin. And then we want whatever they've chosen. So you have chosen miles. We might need blank lines around that as well. So I might try a blank line there. And then, having confirmed their choice, we can then return their choice of unit. So that should cure there. So here, put a space there, space there, space there. We don't need that now. So we could do that. So we have to output the heading first, get both the units, then we could confirm that. We can now tell them what they're converting, couldn't we? That's where we can say what they're converting from and to. Again, we might want a blank line. Not sure about that yet. Then we ask them to enter the number of whatever units they're entering. Let's try that. Okay, that looks better to start with. I have chosen miles, yes. I have now chosen feet. I'm converting miles to feet. Enter the number of miles. I need a space before that. And otherwise we're there. I think I like a blank line before the end. There, so enter the number of miles needs a space. And the final result, where's the final result printed out? So output distance does have a space, but I'm going to give it a blank line. As well as a space. And let's have a blank line at the end as well. One more test. 3, 1, 1. Okay, I'm happy with that.